Okay, so today we are going to be looking at the quotient rule. So this is when we are dealing with functions that involve a division of two simpler functions. So first we can attempt to differentiate by simplifying the quotient first, hopefully the quotient will disappear, or we could also write it as a product and use our product rule in order to take the derivative as well. So let's, for example, take a look at the function f of x equals 6x squared minus 8x over 2x and try to simplify it, and then try and take the derivative by writing it as a product and using our product rule. So if I'm taking a look at simplifying it, I notice I can factor a 2x out of the top, and I get 2x times 3x minus 4, which allows the 2x now to divide out. So I actually am just looking at a function that is like 3x minus 4. Right, and now I can take the derivative of that, which would just be using our power rule of 3. Or I can write it as a product, right, which would be 6x squared minus 8x times 2x to the negative 1. Right, so if I just distribute the negative 1 in, my f of x is 6x squared minus 8x times 1/2 x to the negative 2. Right, and now I can take my product rule from yesterday to this. So my derivative is second times the derivative of the first plus first d second negative hold on there. This should be a 1 up there. There we go. So negative 1 negative 1x to the negative 2. There we go. Awesome. So let's simplify that a little bit. What do we got? We've got, because that should be a 1. We got 6 minus 4x to the negative 1 plus, minus 3 plus 4x to the negative 1, which just leaves me with 3. Right? So that's, a couple ways that we can do it. This isn't always going to work. Right? Unfortunately, we cannot always use those techniques, so we need the quotient rule. Well, let's prove that like we did the power rule and the product rule. So let's have a function q of x be the division of the function f of x at g of x. Right? Okay, so then my derivative q prime of x would be my limit, right? Using those first principles to take the limit of, what do we got? We've got f of x plus h over g of x plus h minus f of x over g of x all over h. Right, there's my limit, first principles, definition of a derivative. Okay, well, let's find a common denominator for that numerator. limit as h approaches 0. So I'm going to have g of x, g of x times f of x plus h minus f of x times g of x plus h all over g of x times g of x plus h, right? And that's being multiplied by my 1 over h. Okay, so like with the product rule, I'm going to force in a couple terms there so that I can have something to common factor with. So I'm going to have the limit as h approaches 0 of, I'm just going to write my f first, f of x plus h, g of x, and I'm going to force in f of x times g of x. So first I'm going to subtract f of x, g of x, and then I got to add it. And then I've still got that minus my f of x, g of x plus h. All of that is over my g of x plus h, all being multiplied by my 1 over h. Okay. So now I'm going to split that up a little bit, right? Because if you notice, my first two terms in my numerator have a common factor. My second two terms have a common factor. So let's split that into 2. So I've got the limit as h approaches 0. Okay, so again, because both of these are being multiplied by h, I'm still going to have that times my 1 over h. Okay, I'm going to keep it as subtraction, right? Because originally I was subtracting two things. So if I subtract here, that's just going to flip the order of these two. So I've got my limit as h approaches 0 of f of x times g of x plus h minus my f of x, g of x, all over the g of x times g of x plus h. And that's all being multiplied by my 1 over h. Okay, so I'm going to kind of common factor some things out here. So if we take a look at, then if I'm going to have my limit as h approaches 0 of, I can common factor out that g of x. If I factor out that g of x, keep that denominator on the bottom there. Okay, that's being multiplied by, on the top then I would have f of x plus h minus f of x plus h minus my f of x left in my numerator, and my denominator has that h. Well, hopefully that looks a bit familiar. F of x plus h minus f of x all over h as the limit h approaches 0. Right. If I do the same thing For my second limit here, I can factor out that f of x on top with my denominator of g of x times g of x plus h. That's being multiplied by what I have left up top, which is my g of x plus h minus g of x over my h, which again should hopefully look familiar. Okay, awesome. So what happens then is I take my limit as h approaches 0. Right, if we want to there, maybe. Let's just show. Well, as the limit as h approaches 0, I'm able to actually split these two up. Right, so I can, properties of limits. Notice how I did not divide out those g of x's because I still have a denominator of g of x, so I can find that common denominator anyway. Okay, so hopefully my two limits there look familiar as being the limit definition of my derivatives, my first principle of the derivative of f of x and the derivative of g of x. So let's take those, take the limit now as h approaches 0. So if I have the limit of h approaches 0 of g of x over g of x times g of x plus h, well, this is what we're finding. So if I take my limit, then I'm going to have g of x over, would just be end up being g of x all squared, right, times my derivative of f of x. Subtracting, well, if I took that second derivative there, second limit, I get f of x over, again, g of x squared times the derivative of g of x, which, if we combine these, collect my like terms, right, actually subtract them with the common denominator, I get g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. And there is my product rule, or sorry, quotient rule. There is my quotient rule, right? Remembering that g of x was my original denominator, f of x was my original numerator. Right? So rather than trying to memorize that again, got a cool little way to help say this, to help us remember. So that is bottom d top minus top d bottom all over the bottom squared. Right? So bottom d top minus top d bottom all over the bottom squared is a nice way to help remember the quotient rule. Again, you'll remember this in 10, 20 years, rather than thinking, okay, I'm taking the numerator, denominator, derivatives, right? Bottom d top minus top d bottom all over the bottom squared. It's my quotient rule. All right, so let's now apply that. Okay, let's differentiate using my quotient rule. Okay, so this first one here, we actually don't even need to use the quotient rule. Reason being is my denominator is simpler, right? Denominator is just a monomial. Right? So you can absolutely go and use the quotient rule. It'll work. But because it is just a monomial, I can simplify each term in my numerator. So I have, then if I simplify that, I've got 4x squared divided by 3x. Well, that just leaves me with 4 over 3x minus 5 over 3 plus 2 over 3x to the negative 1. Right? That now allows me to just use my product rule to find the derivative. So that's going to leave me with 4 over 3 plus, oh, not plus, 4 over 3. And then we got minus 2 over 3x to the negative 2. Okay, so we could leave it as that or just simplify it a little bit here. And I can factor out. I'm going to factor out a 2 over 3x to the negative 2, which will leave me with 2x squared minus 1. So I'm going to get 2 over 3x squared times 2x squared minus 1 as my derivative. Again, you would find the exact same thing if you did use that quotient rule. So let's go ahead and use the quotient rule here on the second one, on my g of x. So my g prime of x, I'm just going to actually move that over a little bit. G prime of x. All right, so I'm going to do bottom d top minus top d bottom all over the bottom squared. Okay, so bottom 3 minus 4x, bottom d top, so the derivative of my top, which is just 2, minus my top times the derivative of my bottom, which is just negative 4, all over the bottom squared, which is 3 minus 4x squared. Right, so we are not going to expand that. Right? There's no need to have to expand it. If it was a simple one like a monomial, yeah, we could expand it if we did use that quotient rule in the first example there. However, when it's a binomial there, just leave it. There's no need to expand it there. It's already nice and simplified. All right, so let's just simplify that top. And we get 6 minus 8x plus 8x minus 20 over 3 minus 4x all squared, which gets me to negative 14. Over 3 minus 4x all squared. Awesome. Okay, let's try another one here. Okay, we're taking note that our numerator is actually a product. So when I'm taking the derivative of the top, I'm going to use my product rule. I can expand it if I wanted to, but let's see if we can do them without having to expand it. Okay. So then my y prime, so bottom 3x plus 1 times the derivative of the top. Right, when I'm finding the derivative of the top, I'm doing my product rule. So second d first plus first d second. So second d first plus my first d second. Right, so there's my bottom d top minus top So 2x plus 1, 3x minus 2. So there's my top. D bottom, it's just 3 all over my bottom squared. Okay. Awesome. So what can we do here? Well, let's just simplify, collect some like terms here. Okay, alrighty. So we've got our 3x plus 1. Simplify these brackets. And let's expand these ones. All over. We're not going to expand that bottom bracket though, because we know what it factors to already. It's already factored for us. Okay. Simplify some more. Oops. Three x plus 1 all squared. Okay, almost there. 36 x squared plus 9x plus 1 minus 18x squared. 3x plus 6. Okay. So we get 18x squared plus 12x plus 5 all over 3x plus 1 squared. Awesome. I think that's about as simple as we can get there. Cannot factor that numerator at all. All right, next example. Determine the point on the curve y equals 3x over x squared plus 4 where the tangent is horizontal. All right, so remembering tangent horizontal is meaning that we are looking at our y prime being 0. Okay, so let's find that. So first, if we're looking for y prime being 0, we need to find y prime. So my derivative, bottom, d top, minus top, d bottom, all over the bottom squared. All right, so let's just clean it up a little bit there. 3x squared. Okay, so my derivative then, you get negative 3 times x squared minus 4 over x squared plus 4 all squared. right? So we're going to let our y prime be 0. Well, if I'm looking at a fraction being 0, all I really care about is the top, right? My numerator. So then that means my numerator must be 0. Okay, so that means that my x squared minus 4 is 0. So I'm getting x to be plus or minus 2. Alrighty, well, let's just see what happens. So when x is equal to 2, or when x is equal to negative 2. When x is equal to 2, my y, I get as 6 over 4 plus 4, so I end up getting y is 3 over 4. When x is negative 2, my y I get ends up being negative 6. So I get negative 3 over 4. Alright, so the points are 2 and 3/4 and negative 2, negative 3/4. Right, so those are the 2 points on the curve where the tangent is horizontal. Awesome. So let's look at 2 last examples here. And again, we're going to try and do them without expanding the numerator. Right? So we're going to have to be using that product rule when I'm taking the derivative of the top. Right? So maybe take a pause, see if you can go through and solve them yourself, and then check your answer. Alrighty. So we've got bottom, d top, so that is going to be second, d first. I think I'm going to end up doing the second one on a different page. Second, d first plus first times the derivative of the second. So that's bottom d top minus top d bottom. Yeah, so that one's going to be done on another page. All over the bottom squared. So 3x minus 4 all squared. Okay. All right, let's simplify this a little bit. Oh, I've got 3x minus 4. Okay. Simplify this, I get, okay. Well, from that 6x squared minus 10x, I can take out a 2x. $3x minus 5. You know what, let's actually expand that last little bit there. Is that 6x squared cubed plus 15x squared. Don't have to expand that, but going to. 98. Right, so I can actually take out an x from all of my terms up top, which is going to leave me with 2 times 3x minus 4 minus 6x squared plus 15x. Well, this is getting ugly. Okay. Y prime. Let's simplify this inside here. I've got x. Alrighty, so I'm going to have 18x squared. Minus 54x plus 40. Alrighty, awesome. So I think my last step should hopefully just be, I know this is going to look ugly, but I ran out of room on my little itty bitty screen. Alright, so I've got x times 12x squared minus 39x plus 40 all over 3x minus 4 squared. And I do believe if we take a look at that, I cannot factor that. I don't believe. So there's my final answer. Alrighty, so again, like I said, I'm going to take a look at that b on a separate page here. Alrighty, so let's remind me what it was. Alright, it was f of x. I was looking at 2x plus 2 times 3x minus 1 all over x plus 5. Okay, so now let's find the derivative. Alrighty, so my derivative, bottom, d top, so doing the top is going to be second, d first, plus first, d second. Okay, bottom d top minus my top d top d bottom all over the bottom squared. Alrighty, simplify some things up here. We got 6x minus 2 plus 6x six minus, well, I can factor out a 2 there. So that's, yeah. Okay, all over my x plus 5 squared. Okay. Oops. So I'm getting 12x plus 4. Again, if you're simplifying this a different way than I am, that's absolutely fine. If you expand things before, well, like whatever you do, it's fine. It doesn't have to be the exact same way that I'm simplifying it. I'm going to factor out a 4 from that second bracket there. Okay, well I can factor out a 2 from everything. So I'm going to take that 2 out, and then I'm going to expand all this stuff. So if I take 2, okay, so 6x squared and what do I get? Plus 32x plus 10x. Oops, just 10. 10. And then I'm going to have minus 3x squared. And what do we get? Minus 2x plus 1. Alrighty. So I think I've got 2 times 3x squared plus 30x plus 11 all over my x squared, x plus 5 squared. And again, I don't think I can factor that numerator in any way. So there we go. Alrighty, so there's my quotient rule. Right? Again, using that when sometimes we can't necessarily write our quotient as a product, or maybe we're not a big fan of the product rule, so maybe we will become a fan of the quotient rule. Right? So there's some practice work on page 150, numbers 4 through 12. Right? So again, if you have any questions, put it in the chat, send me an email, and I'll get back to you. Take care.